Hello, welcome to the channel Easy Way to Physics with Jaya. Today we will learn about ray diagrams. How to draw the ray diagrams when the object is placed at the center of curvature, at the focus, between center of curvature and focus, and at infinity in case of concave mirrors. Shall we go to the videos? Before that, if you did not subscribe my channel, please subscribe it. Tap the bell button also to get the notifications. Now we will start drawing the image formation in concave mirror when the object is kept at C. Here a concave mirror is drawn, pole is marked, center of curvature is marked, which is the center of the circle of which the mirror is a part, center of curvature. Then focus. Focus is the midpoint between pole and center of curvature. Now the object is kept at C. We will see how the image will be formed. Object at C. Then two rays starting from the object we will draw. First one is starting from the top parallel to the principal axis and reaches the mirror. C. Starting from the object parallel to the principal axis reaches the mirror, which will pass through the focus after reflection. We learned the ray which is parallel to the principal axis after reflection will pass through the focus. Now the second ray will start from the object, pass through the focus and reaches the mirror. After reflection it will go parallel to the principal axis. So see, it is passing through the focus and reaches the mirror. This is the focus. We will keep the mark here. And when you draw, use a sharp pencil, otherwise it will be difficult to get. Reaches the mirror. See, passing through the focus and reaches the mirror. After reflection, it will pass parallel to the principal. This is the principal axis. Parallel to that, we have to keep the scale. Goes like this. Now, see, the image is formed here. Just below the object, the image is formed. So image we can draw with dotted lines if we want. Okay. Now see how the image is got. It is of the same size of the object. It is inverted. So same size. Same size. Inverted. And where we got it at C itself. And it is real also. Since the rays are meeting really, we got the real image. So real inverted and of the same size image we got. If the object is at infinity, how we'll get the image? To draw the object at infinity, you can draw two parallel lines. Two parallel lines, lines which are parallel to the optic axis. Now I am drawing an object here. It is far away from C, so we can consider it as infinity. So from the object, two rays are coming parallel to the principal axis. This is first ray, reaches the mirror. So first, after reaching the mirror, what will happen if parallel rays fall parallel to the principal axis? If a ray is falling on the mirror, after reflection, it will pass through the focus. So I can draw it like this, through the focus. Now one more ray I am taking. The second ray starting from the bottom of the object. That is also parallel to the principal axis because it is coming from infinity. It is parallel to the principal axis. That ray also, after reflection, passes through the principal focus or focus. So it will go like this. So two rays, where the two reflected rays are meeting at the focus itself. So the image will be formed at the focus. But see its size, it is a very small pointed image. So the image what we are getting will be pointed image at the focus. We are getting at the focus, image at the focus, and it is a pointed image, very small image. Infinitely small image is formed at the focus. Same way we learned, if the object is placed at the focus, we'll get the image at infinity. We cannot see that image at all. It is at the infinity. And if the object is placed at infinity, we'll get the image at the focus. If the object is kept at the focus, how the image will be formed? Here a concave mirror is drawn. Its pole, center of curvature, focus. All these are marked. Now we are drawing an object at the focus. That is perpendicular to the principal axis. C. And from the objects, two rays will be started. One is parallel to the principal axis and reaching the mirror. After reflection, it will pass through the focus. We learned the ray which is parallel to the principal axis after reflection passes through the focus. So we will draw it like this. Next ray. So the first ray is completed. Second ray passes through the center of curvature. The ray which is passing through the center of curvature after reflection will be reflected back in the same path, right? The ray which is passing through the center of curvature and reaches the mirror will be reflected back in the same path. So we are taking another ray which can pass through the center of curvature. See, like this. So when we keep the scale, we will keep it like this. Starting from here, reaches the mirror. Now I kept the scale like this, which can pass through center of curve. So after reflection, it will be passing through the same path. So see. So the ray which is passing through center of curvature will reflect back in the same path. See the two rays. Two rays we took. One is parallel to the principal axis. After reflection passes through the focus. Second ray, another ray which is falling onto mirror and reflecting back through the center of curvature. These two rays are parallel to each other. When the object is kept at the focus, we did not get any image because these two reflected rays are parallel to each other. They are not meeting at a point. What does it mean? This means that no image is formed when the object is kept at focus. No image is formed. The reflected rays goes parallelly. This is why we are using concave mirrors in the headlights of vehicles. In the headlights of vehicles, we are keeping the bulb at the focus of a concave mirror. In the headlight, there is a concave mirror. At the focus, we are keeping a bulb. And this bulb, the light from the bulb reaches the concave mirror and reflects back parallelly. That means we will get the light at infinite distance. Far away, we will get the light. After reflection, those rays goes parallelly when the bulb is kept at the focus. If the object is between C and F, how will be the image formation we can study? So in that case, we will draw the object between C and F like this. One object we are drawing. When you draw, you have to draw with sharp pencil to get the correct position. Okay, so this is center of curvature C, focus F and pole P. Between center of curvature and focus, the object is placed. Now how will you get the image? For that we will take two rays, one ray parallel to the principal axis reaching the mirror. That ray after reflection from the mirror will pass through the focus. This we did now many times, so it will be easy for you now. Now second ray is passing through the center of curvature. So we will take a ray which is passing through center of curvature like this. See, this is the center of curvature. The ray should touch the object. From the object it reaches the mirror. Now one part is over. After reflection it will come back in the same path. So we will draw it like this. Reflected ray I will draw with black. It is coming back with in the same direction. So see, the ray starting from the object reaches the mirror and coming back. And both of them are meeting at this point. First ray crossing the second ray at this point. So here the image will be formed. See how the image, it is bigger, isn't it? A very big image, inverted image, and it is formed beyond C. So the what is the characteristics of the image is beyond C, enlarged image, enlarged, inverted, and real. Enlarged, inverted, and real image is formed beyond C. In short, we can say when the object is coming nearer to the mirror, image will go away from the mirror. And when we study, we can study like this. When the object is at infinity, image is at F. When the object is at F, image is at infinity. Then, when the object is beyond C, image is between C and F. When the object is between C and F, image is beyond C. When the object is at C, image is also at C. And all cases, real inverted images are formed. When the object is at C, same size, and object is beyond C, also at infinity, small images are formed. And when the object is at F and between C and F, images formed are enlarged. And when the object is at F, at infinity, we can say it is highly enlarged or we cannot see at all. Both we can see. Now one more case is there when the object is between F and P, between focus and P, how the image is formed. That we will see in the next video. Children, do not forget to tap the bell button when you subscribe the video, like and share with your friends. Thank you.